All right, kids, here's a couple of the problems about finding the sample size that you need to meet a certain confidence level with a certain margin of error. So, for example, find the most conservative sample size needed to create a 93% confidence interval with a margin of error of 3.8%. When I say most conservative sample size, I'm saying our p hat is 0.5. That leads to the largest possible sample size that we need, the largest, smallest sample size. So the first things first, we need to figure out a critical value for a 93% confidence interval. So remember that we draw our normal curve, and the 93% confidence interval just captures the middle 93% of this normal model. And so that's 7% on each side. So there's 3.5% on the right and 3.5% on the left. And so I take this 3.5 and I use the inverse normal command to find the z-score. So I turn the percent to a decimal, and the mean of 0 and the standard deviation of 1 because I'm dealing with z-scores. And this is my z-score. So that's negative 1.8, which means this is 1.8 over here. So the critical value I always use the positive critical value. Always, 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 always use the positive critical value. So I write my margin of error equation. The margin of error, the special z-score, the standard error. Type this into my calculator, and then I go comma n, and I use my solve command, and that gave me an answer of 568.39. We always round this up. Always round this up. If I rounded down, I would not have enough people to get within my my margin of error of 3.8%. So we always round up, and we use 569 people. In practice, we would probably just use 600 people and be done with it. So again, here's another example. I think the hardest thing is going to be getting the critical value for you. So find the most conservative sample size needed to create an 80% confidence interval with a margin of error of 2.1. Most conservative means my p hat is 0.5. And so I draw my normal model, and I mark off the middle 80%, which gives me 10% on the left and 10% on the right. And I use my inverse normal of 10%, and that gives me negative 1.28155, and I always use the positive, so my critical value is 1.28155. And so then I write my margin of error equation. So here's my margin of error. Here's the special z-score that makes 80% confidence, and this is my standard error right there. And I don't know what n is. So I'm going to use my calculator. I'm going to use the solve command on my calculator. And I go comma n at the end. And my solution is 931.049. And I always, always, always round that up. So I'm going to round that up to 932. In practice, I would probably just choose 1,000. Here's one more example. And I'll give you a problem to try on your own to see how you do. So again, find the most conservative sample size needed to create a 90% confidence interval with a margin of error of 7.9%. So 90% confidence we know has a special z-score of 1.645, or with a few more decimal places, 1.64485. I set up my margin of error equation. So here's my margin of error. There's the special z-score, and here is my standard error. And then I use my calculator command, the solve command with a comma n at the end, and that gave me 108.377. We always, always, always round this up. Always round that up to 109. So here's one for you. Give this one a try. I've covered up my answers. All right. So find the most conservative sample size needed to create a 98% confidence interval with a margin of error of 4.5%. So pause this video right now, find the critical value, work through this problem, and make sure you get the same sample size I do. I'm going to hope that you actually pause the video to do this. So my critical value is 2.326. For 98% confidence, we probably use 2.326 or maybe 2.33, but that's what it is to 5 decimal places. And then my sample size looked like this. There's my sample size. And my equation that I had to solve, my equation would have looked like this. 0.045 equals 2.32635 times square root of 0.5 times 0.5 over n. So again, that's finding sample size. This is one of the things you'll need to do on Thursday for the quiz. So again, look at this, ask questions, and I certainly hope this has been helpful.